Good morning, everybody. It seems like we are live. Good morning, everybody. Again, welcome back. All right, so yeah, let us say this day, today, another episode, chapter, okay, 3.27. Left, it was yesterday, and 3.27 today, write a function map once again. Yeah. Because this function is very famous and very useful, and it's good to have it in several data structures available to transform them analogous to the method of the same name on list that modifies each element in a tree with a given function. And in here, there's no type signature. In here, so we need to come up with the entire thing. And as always, we will be taking a look at here to make sure we are streaming. We are plugged, in the energy. So hopefully that won't cause another interruption. We have this the starting code URL in the description if you want to have a starting point and stop the video, you know. And we have some trees over here. So we have first this extension method for trees of type in, but map should work for any tree, any given data type. Apparently. So I forgot my chalkboard. I was uh, I was I was amplification, prepare, no. Well, no drawings for today, sorry. But if we need it, we will do like the filter function that we exercise the entire thing over here. So, let's get started. Video starts at 3.5 minutes. All right. So again, over here, let's write a function map of type A. We'll come back to this in a minute. And the arguments will be a tree, type A, and a function. The book doesn't mention any more details, but since it is analogous to the list, the map list, map the map in the function in the list data structure, we can think of the type like this. Now that we have spotted another type variable, we can go back here. And since uh, the tree will be transformed by the function, the element, we will be delivering a tree of type B, and we need and we need to start matching. Okay. Now, the base case, if you have a tree with one only with a leaf, in the past, I believe people exercise imagination a little bit more. And these days, I don't have any data supporting my saying. Well, I'm thinking this because now you have to imagine in your head. There is no chalkboard. Imagine circle. This you can color in your mind. See it, circle, and a number 5. That's your tree, with which is only a leaf, and you want to transform the element with a function. Okay, so that's why it. Okay, leave in here. We don't want to say I don't care because we care. We need to transform the value, and now the what are we writing over here is, so I will say I will write the value, but then you will be returning A, and then the guy, another person will say, I will apply the function to the value, but then you will be returning B. And then a third person will say, okay, I want to build upon the knowledge of these previous persons, to previous persons, and build from that. So I suppose it is leaf of f of value. You have your type A, and Scala is helping us. We have our type F. Okay, this will give us a D. It's a function type application. And then we have this data constructor, which will give us this. I think we have covered the base case. I don't know. I don't know if this is going to work. If this is going to work, well, now we have the. Okay, we are still alive. Live. Right? I remember at the beginning what was happening to us a lot. What was happening? We were writing the cases like this, and now our brain have accustomed to the fact that in a Scala you have to use this case. Just you know, case branch left, right. Now what are we putting here? Okay, we need a 3 of type B. So we are going to start with that. You can say I can give a 3 of type B with this leaf. But then you don't have any uh, value over here to apply the function. So I think we have to use branch to construct tree. That is, we have open and close parentheses, and we have this constructor branch. It expects a tree of type, uh, the type of the tree, one in the left and one in the right. Okay, so we need to provide two trees over here. Right. At the same time, we need to transform the element of the tree to be of type B. So we write the comma. How can we provide two trees? Well, we can say, okay, left, right. Well, this will be of type A. Okay. So it seems like we need to call map, because map, look at this, map is also highlighted over here, map, will give us a tree of type B. We need another one here. And we need to give a tree of type A. We have one over here. Left. We need to give a function f of type A to B. We have one. Same for this. I think we are done. I suppose. Hopefully we are done. Okay, now it's time for let's start with this. Okay. 3-1. Do you think uh, this is going to work? Do you think this syntax will work over here? If it doesn't, we shall expand this, right? Again, level up for the better, for the best. And we have leave 10, leave 100, which is what we expect. So I suppose we are done. Now a more complex one, this. And now let's double two, okay, 18, 4, 10, okay. You can, exercise with a tree of type of string, a tree of a string. In the case you don't know what's happening here, we there's a function How can we expand this? In 15 minutes, I think that we need to, we can, end the thing. But, let us take the risk of sailing over here, okay? I plus 5. Well, I know you knew what was happening, but let's try this, in the case you weren't sure. This is a function, receives a value and adds 5. And it like it, you know, 14, 20, 14, 22, 4. So yeah, what's the other syntax? Uh, do you think this is going to work? I don't think so because there is no parameter for y. There is no like. Oh yeah, it works. So these are the three forms of sending the same function expression. Is is great. Whatever you like the most. All right, so we are done. I like it, the first one, but uh, it's okay for you too, because I like, those 10. So we saw the three ways, but this is like just the we just delete what we are annotating the type. It is not required because Scala is an advanced uh, compiler system that can infer this. It's okay. We are done. You need to be celebrating. I will turn my attention to, let's see what we have over here. Okay, well, I want to show you this book, Methods of Logic. 18 minutes, I think we can talk 2 minutes about anything. Yeah, Methods of Logic. I am on chapter 7. I am going to invest 1 hour in this book today. This was next for me. I do have another book on logic. In here I am on chapter 4, but I hit an obstacle in the software that it is includes a pitch. I don't know what kind of constraints are needed in the software. Yeah, a little bit of mathematics maybe in Nike. I'm not sure. I will throw some dices to see randomly what. I do have some job interviews. Well, I have one. I am looking for a job, if you don't know. And what else? 30 seconds. Yeah, have fun and have a good day. Stay tuned for the next live session, coding session. And thank you. I know there's no one here, but in the future. Thank you very much. Bye for now.